People at home, check it out. 500 gram mass, spring scale. I think you guys know what we're about to do. Let's see what weight we get. Pull it up. Yep, just like we thought, right at 4.9. Yeah, that's exactly right. 500 is 0.5 kilos. Multiply that by 9.8, you get 4.9. So right there. All right, now let's try this. Let's attach it to a pulley. All right, so the weight's gonna hang down there. I'm gonna attach the spring scale right there. I'm gonna pull down on the pulley so it pulls the mass up. I'm gonna pull down on this string with the spring scale so it pulls the mass up, and we're gonna measure like the force needed on the spring scale. So go ahead, make a hypothesis right now. Is it gonna be less force, more force, or the same force? Looks like it is the same force needed. The same force. Why is that? Write me a sentence. Why is it the same amount of force to pick it up as it is to pull it down using a pulley? That's right. See, the pulley doesn't make it any less or any more. It just changes the direction of the force. So instead of pulling directly up, I'm actually pulling down and it's moving up. So let's look at another situation. Let's look at where there's two pulleys working together to lift this object up. So check it out. We still got the one pulley up top here. All right, it's going around. The string is. And now it goes down to this pulley right here. That pulley right there. This pulley is attached to the mass itself. And the string goes back up and anchors to the original pulley. So go ahead and tell me what's your guess. Do you think it's going to take less, more, or the same amount of force to lift this pulley? Less, more, or the same amount of force? All right, let's check it out. Let's see. So I'm lifting it up. Takes right about there. 2.5 newtons. So it's exactly half the amount of force to lift using two pulleys. Okay. Oh, the thing just came out of the, wow. All right, that's new. That shouldn't have happened. That's all right. So exactly two. Go ahead and tell me why that is. This is a situation, all right, where you see how it takes less force to lift an object than it actually requires to be lifted. This is called mechanical advantage. We calculate it like this. So in the case of our mass, right, it was 0.5 kilograms. So it means it had a weight that was equal to 4.9 newtons. But we were able to lift it. We only did a force applied equal to 2.45 newtons. So our mechanical advantage, we had a mechanical advantage, which I'll write as just MA, equal to 2, which really is just, you take the weight and you divide it by the amount of force or the force applied on the object. So again, another example. What if you had an 80 Newton object right here, but it only took 10 newtons of force to lift it? What's your mechanical advantage? Good job, it's 8. Your mechanical advantage is equal to 8. We use this and we can set up pulleys like this. Each pulley, you get to divide the answer in half, or you divide it in half. So if I had 3 pulleys, then the force I applied would only need to be about 9 newtons. And then again, if I added another pulley, my force applied would only need to equal 0.95 newtons. So you see how every pulley you add, it just cuts the force you need in half. Now, the only caveat to that is that it cuts the length in half, or it cuts the length in which you pull it in half. So watch this. As I pull this out, look how far I pulled it out, and yet our mass only travels that distance. I pulled a much longer length than the mass traveled. Our mass traveled half the distance for which we pulled. So even though we pull with double the power, we only pull half the length. So each pulley you add makes the length you have to pull doubled. So for a regular pulley, all right, if I want to pull up 10 centimeters, if I want to move this object 10 centimeters, well then I'll just pull down by 10 centimeters. But if I have a double pulley, all right, where I have two pulleys, and I want to pull this object up 10 centimeters, I have to pull down by 20 centimeters. And so on and so forth. If I have three pulleys, all right, it would look like this, and I want to pull my object up 10 centimeters, well, I have to pull down 30 centimeters. So you just multiply however long you want to pull it by, or the length you want to pull it by the number of pulleys you have, and that tells you how far you have to pull it and how much rope you need.